I'm gonna try to be quick.
I'm still sorry.
It's no problem. It's no problem. So, okay. Well, hello everyone. My name is Carlos Rodriguez. I am the CEO of Orbital Space Technologies, which is a Costa Rican-based company. And what we do is we develop a service to do microgravity experiments and manufacturing in space, especially on the biotechnological side. And I'm also doing my master's right now here at the it's a master in space technologies and business. So I've been working on space missions for a while now, and I was able to lead Costa Rica's second space mission. So to start, I wanted to ask you one very important question that every person that is not from space, or from the space sector, is going to ask to you if you pitch a space project to them. And the first thing they ask is, why space? Why is this important? Does anyone have an answer? I already had one on the chat, but I want to know, does anyone in the audience have an answer for that? Why space?
Okay, because at least for me, it's why not? I mean, space is so large and so unexplored that there are so many marvels and so many answers that you can look for. So just the chance of trying to satisfy your curiosity of what's out there, what you can do, can't do, is almost just that itself makes it valuable enough to go.
Yeah, I completely agree with you on that sense. And for people like us who are interested in the topic, that's definitely a right answer. But I mean it on a more pragmatical way. Why is space important? What are the benefits that space companies and governments are searching on space? I think I see a raised hand. Yeah, please go ahead. I cannot.
Where's the mic?
It's here. You can speak. Speak loudly.
Okay. So I do feel like how recently they've been like doing like going to Europa or like trying to find like more opportunities for life.
Hmm.
Like I've seen some like the more recent like space missions to kind of see where can it be possible to find like other places to live.
Yes, yes, that's definitely true as well. So I'm going to tell you a little bit about the benefits of space, so that next time someone asks you this question that is not from space and does not understand why all of these things matter, you can give them a little bit of an answer for all of the possibilities, because there's a lot of sectors that can be covered here, and a lot of places and applications that you can basically link to space. So for me, one of the most obvious ones, and this is why our company does what it does, is microgravity. So when you're in space, you're subjected to. So basically, you don't have to deal with as large of a gravitational force as you do here on Earth. Of course, there's gravity, but you don't feel the effects of it because you're always on a free fall. So what happens is that you basically don't have that. And that is very interesting because it does a lot of things different than on Earth. For example, microgravity is a biological process accelerator, because when you get biological beings that have evolved to exist in a gravitational environment, and you take them out of that gravitational environment and put them in a different one, they try to adapt to survive because it's an extreme environment they're not accustomed to. They don't have the ability to survive in it, right? So a lot of biological processes start to happen. And then basically what happens is that you see gene expression changes. So you see changes in the composition of how their genes are coded in the way that they express different behaviors, right, than what they do on Earth. So you can see, for example, in plants or in fungi, rapid growth rates that you cannot see on Earth, or different patterns of growth. There's a lot of science that goes into studying those kinds of things, and some of those effects can also be studied there and then brought back to Earth to be able to be used as products and as enhancers for life here. For example, in the pharmaceutical sector or in the agricultural sector to develop medicines or develop stronger plants, right? So there's a lot of benefit to that. The other one is it is a unique environment to create new materials because when you don't have gravity, uh, you don't have many vibrations because you're basically always on a microgravity environment. You uh, can do, for example, longer crystals. You can also work in ways that are not possible here on Earth. So that is also very important. And also, there are different physical interactions than on Earth. That's there's a typo there. Basically, for example, if you light a fire in space, it will not take the exact same shape that it has on Earth because of how it works. Or if you have liquids in space, they behave differently, and there's a lot of benefit to that as well if you can study it. That's one of the possibilities. The other one is more on the line of what you were saying about life. It's celestial bodies, access to new resources. There are resources in space that we cannot into yet, but are worth trillions of dollars of Earth's money. And if we could tap into that, there's a lot of benefit to be had. Um, it also going to these new celestial bodies, doing these types of missions and experiments allows us to develop further our construction techniques because you have to have a very different way of thinking and a very different kind of habitat to be able to build something there with limited resources, with different forces and environmental conditions. So this also affects our life here on Earth. And then also there's some similitudes on Earth. For example, if you take a Mars rover that is designed to be able to work on extreme environments and you design that for Mars, a lot of that technology will also be useful for exploring extreme environments here on Earth, right? So there's a lot that you can study there. And then there's the satellites and communication sector where basically you have the security part of it, the communications, all of the uh, TV broadcasts, for example, via satellite, anything that you want to see like in real time, like live broadcasting, those kinds of things. Earth observation to just to monitor the earth, to prevent disasters, for disaster relief, to know what is happening at a given point that may be difficult to access at any time. And also there's this new trend for LEO. LEO is low Earth orbit, so it's like a small, like the orbit that you can get closer to Earth. Um, that in the future will include mobile data and streaming services. This is already happening. You will start seeing how in the next few years you will be able to satellite plan for your cell phone and just connect directly to a satellite. Apple already does this for like emergency texts and everything, but we'll talk about that later. Uh, and also you have a unique reach to all of the planets. So you have a very good vantage point from where you can see maybe half of the planet, maybe a quarter, maybe all of it. So it depends. Well, not all of it, because when you see half of the planet, you cannot see the other half. But you also have this vantage point from where you can see the whole Earth, and that's very valuable. And the thing with this is that we've talked about very different fields, very different things, and then space really touches on all markets on Earth, and that's really important because then it makes it an asset that you can exploit on different trends. Um, so that was just to give you a brief overview of why space is important. And I know you guys are here to talk about space mission design. So let's do that. So, okay, basically, and this is my categorization of space missions, but I believe there are four types of space missions. You have validation missions, which, as the name implies, are to validate technology or validate something in space. You have exploration missions, so more on the type of what NASA does when they send a probe to study if there are traces of life on Mars, right? That's exploration. That's a different kind of mission. You have R&D, more on the line of what I was talking about. You can develop cures. You can work on the commercial aspects of it of this research and development phase on space, and then there's the commercialization of it. There are companies right now that offer satellites that are able to connect with ground stations here on Earth to provide services. There's also a whole new space trend coming out. These new companies like SpaceX that are built to develop services, to develop things that have to do with space in a more commercial manner, quicker, cheaper. So those are basically the four types. And well, as I was telling you, validation missions to validate technology on Earth. This is a launch. Sorry. This is the launch of our technology. This is a validation mission we did, Orbital Space, to basically validate that all of the technology we built was actually able to work in space, right? So this is the rocket launch for that, and then it was in space for a few minutes, where we were able to test every single aspect of what we design to know that it will actually work in space. So we did that because we needed to build trust with our customers, right? Um, but just the same, a lot of companies have to do that as well, right? So you have satellite validation missions, or maybe you want to validate the solar panel of a satellite. You want to validate a specific aspect of it. Those are all possibilities. Then you have exploration missions, more on the way of let's explore space, let's bring these new photos for humanity. And then you have these very expensive telescopes that cost millions of dollars to make, but it is worth it because in the end you are expanding knowledge. This is more about do I see a question? I'm sorry. Because I have a very screen, it's a little limited. Let me know.
Yes, I do.
Yeah, let me
So
know.
with,
Mhm.
so I heard that, well, I'm not sure if it's the Costa Rican Space Agency or like but I heard that this, like, you guys have done like where do you guys have a launch site? Like, is it here in the country or do you guys do it abroad?
No, yeah, so as you can see here, this is Sweden, and this was, so we partnered with the Swedish Space Corporation. They were the launch providers for this, and they actually contacted us through the people at the Costa Rican Space Agency. So it was a little bit of that, but no. At the moment, we do not have launch sites of this scale on the country. Yeah.
I think that here in Costa Rica, because we're very close to the equator, it would be like an ideal spot to launch.
It,
Since
yeah, and then you have
all I'm
access to
trying,
both the Caribbean and the Atlantic. So yeah, it
yeah,
is a privileged position, but then again, there's a lot of regulations and a lot of technology that has to be developed to be able to do that. It's not as easy. SpaceX cannot come to Costa Rica and just launch a rocket from Costa Rica because there's a lot of ITAR regulations, which are a whole can of worms we won't get into right now. But it is possible. There are companies that do this, and eventually, maybe my vision for the future is that in maybe 10, 20 years, we will have a group of Costa Ricans working on developing something like that and having the capability on Costa Rican soil as well. Just to keep on advancing because I have a lot of slides and I don't know if we have that much time. Um, So there's exploration missions, as I was telling you. This is more on the line and the same vein as rovers, as the Hubble telescope, Kepler, those kinds of things, right? These satellites that go through the moons or the planets and give us information on them. That's the kind of missions that they are. Then we have research and development missions where you want to study things in space, where you want to find innovative things for that's kind of our space. We do that, but on a commercial manner. So basically, where you want to make studies in space about something, maybe it's human health, maybe it's agriculture, maybe it's physics. You can do all of that. And then there's commercial missions, where basically someone is there's a commercial use for for space, be it research and development or be it manufacturing. So I gave a little bit of an example here. This is Prolia or denosumab. This is a osteoporosis treatment that was basically what they did is they tested it on mice on board of the International Space Station because it basically worked as an accelerator for the process. What would have taken years here on Earth, they were able to very quickly replicate their experiment because on space the bone density suffers an impact way quicker than here on Earth. So they did that to be able to get the FDA approval for the development of this medicine. And there's also things like there's companies looking into 3D printing organs on space, which is something that is very difficult here on Earth, and then bringing them back and having like a perfect organ for someone that needs an organ transplant, for example. So there's a lot of possibilities of things that you can do. Um, these are just a few of those. There are people looking into making silicon wafers to better enable chip development. There's a lot of things. So yeah. So the idea behind this is that they are commercial. And just to give you a little bit of worldwide context, because I think it's important to have like a brief understanding of where everything is heading right now. There are two markets that are projected to be the next boom in the space economy. One is the R&D and manufacturing in orbit market. There's some companies, a lot of companies, trying to develop commercial space stations now. The International Space Station is coming down probably on this decade, and it's already been there for an astounding amount of time. So these new commercial space stations want to do what SpaceX did on the rocket launch sector, right? You can see examples like Starlab, Orbital Reef, which at the moment is not faring so well, but it's still there. You have Axiom, and you have others like BAST and everything. So they are aiming to start operating on the later half of this decade, and there are also a number of players who are aiming to serve these commercial space stations with uncrewed orbiters. So companies that specialize in having also payloads in space, but not on board of a space station. So maybe a smaller capsule that can also orbit and then come back, right? So those things will enable a whole lot of commercialization from hotels. For example, Starlab is working with Hilton to develop the first space hotel, to R&D in a lot of streams, right? And the market is projected to reach 40 billion by 2040, considering that right now it's about 6 billion, sorry, 5 billion, something like that. It's a very exponential growth. And also LEO lower Earth orbit constellations and on-device communication. I don't know why it jumped. And on-device communication from space. So basically, you don't have to connect to an antenna on ground to get service on your mobile phone. You can get it from directly from a satellite, and then you will have coverage all over the world at any point, at any time you need it. And this would be able to change a lot of how we do things right now because, well, you can imagine the possibilities, right? This is where the Apple example comes in because right now, if you have one of the newer iPhones, you can basically, it's not as complex as all that yet, but if you're like in a tricky situation, you got lost or everything or anything, you can send an SMS message um, from your iPhone and have someone receive it through satellite. So there are a lot of things that you can do on that space. And the last one is something more in the future. It's not something that we're capable of doing like on a big scale right now, but it's space resource applications and commercialization in the future. So basically everything that has to do with mining asteroids, finding the resources on the moon, all of this very futuristic stuff that I believe it's going to be possible probably in this century. And sooner than a lot of people think, in my opinion, there's a lot of money to be made there. So there's a lot of incentives. This is just a graph, just to show you how the space economy is growing. As you can see right now, there are especially the one that is very interesting is the satellite industry. It's like valued at 400 billion right now, and it's still expected to grow to more than 800 billion in the next few years. And also you have new space applications also taking off, and government and space budgets still growing well. So there's a lot of possibilities there. And this is a little bit of what those names mean. So you have ground equipment with antennas and ground stations. You have satellite services providing television, radio, mobile connectivity, those kinds of things, Earth observation. And then you have the new space applications, which are commercial space stations, solar power from space, space exploration, asteroid mining, those kinds of things. And their expected growth. So yeah, just wanted to show you that. If you want to look for it, it is available online. So now you know a lot of it, of what is happening in space right now. But why is all of this important? Why is it important to know this specific data, the numbers? Do you guys have any questions, any ideas of why that is?
Can I ask a question about something that you talked about in the previous two slides?
Yes, let me, where?
Like the last slide and the one before it.
This one.
You talked a lot about the economy of the space. Is like space and money related in a way that space is something you just infinitely pour in money and it doesn't give back anything? Or is there sometimes something generated like a revenue from that comes back to people that they can later reinvest?
That is exactly my point here. Unless you are designing a governmental exploration mission, like, the ones that NASA did to like find out about the compositions of planets or whatever, you have to demonstrate a return on investment. If not, it's not going to happen. No one's going to fund it. And you need funding to develop a space mission. It's one of the most crucial aspects. They are very expensive. Sending payloads to space right now, it's very expensive. Even for the lowest price you can get to launch 1 kilogram of mass is still way up from $15,000 for 1 kilogram, and that's just that. That's not counting all of the research that goes into it, all of the manufacturing, all of the hours people have to invest into that, right? So space missions are very expensive. And yeah, all of this commercialization, you do have to get your money back. It is one of the most lucrative industries on Earth in the sense that, yeah, you do have a very big cap, a very big barrier for entry because it is very expensive. But once you get that past that, and if you have a solid business case, it returns a lot. It is an industry that is expected to grow to $1 trillion in the next years. So there's a lot of money to be made there. And the more important thing is, in terms of designing a space mission, is unless you're working with one of these space agencies and doing it for the benefit of humanity, which is great. It's I think one of the more important aspects of space exploration, of space as a whole, you have to demonstrate how you're going to get an ROI, be it on the benefit the benefit and impact that this generates for people on Earth, and that also applies for space agencies, or be it a monetary one. Maybe you are looking to develop a new drug, so to treat some kind of illness or to treat cancer or whatever. So maybe it happens, maybe it doesn't, but at least you do have something that, in case of being like of getting the outcome you expect, you will be able to justify all of the costs that went into it, right? That's very important. That's the first thing you have to think when you are developing a space mission, because if you don't, then you get these very beautiful space missions that no one's going to fund, and that is a shame, because designing a space mission is very intensive. It takes a lot of resources. It takes a lot of time. So you have to be very clear on this from the get-go to be able to justify the space mission and be able to defend it when you come to talk to investors and people who are gonna fund this mission. All right. So now that we have that clear, let's talk a little bit about how to design a space mission. I'm going to give you like a brief overview of how the space mission design works, at least for the early stages of it. And then if you want to ask anything about the later stages, we can talk about it. I have one question. Has anyone ever seen this table I'm showing you? Okay, I'm guessing no, because I don't see anyone. Okay, so this is a compression of NASA's life cycle, project life cycle graphic, right? So what you can see here is a space mission compressed into a graphical output so that you can better understand what's happening. So what you can see on the left side, let's see, okay, over here is the conceptual studies, like when you start to, okay, I'm going to do a space mission, but okay, what is it going to be about? Who is it going to impact? What is happening, like as a very conceptual study kind of thing. Then how the phase A is how I would develop that concept, right? So you start looking into technology. How would it work? How would it happen? Then once you have an understanding of the technology needed to do that space mission, then you start to do a design. That's where you start doing engineering. So you start doing a preliminary design of the technology. Then once you have that, you can go into a final design, and then you construct it and integrate it. So this is where you integrate everything, you do your tests, and then you launch it, and then you have to operate it. And then after it is operated, something's going to happen, right? You have to compile your data. You have to take your satellite to a graveyard orbit, something like that. So this is just to show you, like, every space project has a project life cycle that you have to plan for and you have to think about before even starting to do any engineering at all. And that's the part where I'm going to focus right now, so that you can at least have an idea of the things you have to look out when you're starting to plan your own missions. Because the engineering you guys can do, like, it's going to be difficult, but you have all of the tools to do that, especially in the university you're in, right? But you have to understand these concepts so that you don't lose a lot of valuable time designing something that won't work in the end. So this is a little bit of how the project life cycle works. This is what I use. It's not like written in stone. Some things can change, but it is a very, fairly basic way of seeing it, and it gives you like a little bit of an idea of how the flow of these kinds of projects work. So basically first you have the stakeholder requirement specification. This is the area where you basically understand all of the requirements that this mission will have. And also you do some conceptual kind of things like, okay, is this is this sound? Is my mission sound? What I'm trying to study, what I'm trying to do, does it make sense? So you do that first, then you understand like all of the needs that everyone involved in this mission would have, including the mission. Then you do a concept of operations, the ConOps, which is basically, okay, conceptually, how will this mission work? And what do I have to do to basically meet the requirements of all of the stakeholders? And once you have that, you have a very clear structure of, okay, I now know all of the phases of my mission and how it would operate. So now I can start designing for each of those phases. So now you have a template of how the engineering, what are the requirements, and then you have the requirements. You can do the engineering to meet those requirements. So you do the system requirement specification. And once you have that, you can do the system design then. So that's where you start working on designing your systems and doing all of the engineering. That's when you start doing your your engineering drawings. You can start doing your prototypes, those kinds of things. Once you have reached your final design, then you can fabricate it and then you assemble it. And once it's assembled, you have to test it to ensure that everything works as you predicted it would, right? So that's the general overview. That's the thing you do always. So let's talk a little bit about those things. For the first part of it, the requirements. So basically you have three types of requirements. You have the stakeholder requirements, which are the ones that have to do with, okay, the people that are funding the mission, the people that are involved in it, like for example, if it's a mission to explore Mars, okay, one of my stakeholders will be the scientific community. What do they want to learn about Mars? Well, what samples should I be taking? What is the most important place for them that I go to explore? Because then once I understand all of those needs, uh, how much budget do I have? What is my time constraint? Those kinds of needs. When you get all of that, then you can start planning for the technology and operations requirements, right? Once you understand all of the needs of the users and the stakeholders, everyone that's gonna be benefited from that, then you can start developing technology that will be able to meet those. And then that's where you start doing the technology and operations requirements. And also there are some external environment requirements. For example, there are some things that will be required not because of the stakeholders or you. For example, if you want to take a mission to Venus, um, Venus has a very unforgiving atmosphere, right? That is not something any of your stakeholders is involved with, but it is something you have to account for when you're developing this project, because your technology must be able to survive those kinds of extreme environments, right? So you have to think about all of these things, and you have to basically map them out. And this is a little bit of a way of doing it. There are other ways of doing it, but this is one of them. So what you start doing is like, okay, you go from the bigger requirements to the finer ones. So you start very big, very high level, and then you start like focusing and making it, sorry, making it smaller until you get into the very fine requirements. So you start on a business requirement setting, for example, okay, how much is this mission gonna cost? What do my stakeholders want from this mission? Is it PR? Is it a cure for something? Is it like a solid space mission where we understand, I don't know, the basic characteristics of Martian soil? Those kinds of things. And then you start going into into the stakeholder requirements, right? On a business operational kind of level. Okay, now that I understand that, what is my time constraint? How do I work on this mission to make it operate as it should, with the limitations I have and the objectives I have? And then you go into the system requirements, then you start doing the engineering. This is another way of like seeing it. But this one has these little boxes in here. And this is really important because, okay, you can start with your business requirements. This is the organization's requirements, like on a broad scale. The project is owned by an organization. It's someone, those are my stakeholders. And then once you get that, you have to compile them in a document, right? That's your STRS. It's a specification. Once you have that, you can develop a concept of operations, and from there you can start working on the business requirements and refining them until you have sufficient information to develop your system requirement specification. That's where you go into the details of the requirements that your hardware must have to be able to meet the demands of the space mission. And then from there, you can start working on the engineering with a template of all of the requirements you have, so that you know which ones you have to like check out. And these are some examples of those requirement specifications. So for the stakeholder requirement specification, it basically characterizes the stakeholders and their requirements. So it includes the types of stakeholders that you have, their approaches, what they expect, the business management requirements for, so the goals and objectives of the project, the business model, the funding you have, the time constraints, the operational requirements of the system. So if it's a mission to Mars, I don't know, maybe it has, you think about, okay, it has to be able to get to Mars. It has to be able to land on Mars. It has to be able to get their samples on Mars. It has to be able to analyze those samples and send some data back to me through an uplink, through like an antenna. And I have to be able to receive that. Up until that point, you have not designed any of these features or any of this technology, but you understand conceptually what it must be able to do, and then you have this map for when you start developing your user requirements, your project lifecycle, and then when you have all of that data, basically in one small package in this stakeholder requirement specification, then you can develop you can start developing your technology based on those needs. So if I have to get this, I don't know, this sample from Mars, I know I have to be able to design some kind of farm that will be able to excavate Martian soil. And then I know how much Martian soil I need. I can go into how will that arm work? So it will need power, how much power? It will need to be able to rotate on its axis and go down. And then those are the system requirements that you start mapping out. And they basically include the purpose and the focus of the system, the functions that it will be doing, like how does it function, and the characteristics. So the requirements of the system, like the functional, the performance, the usability, the maintenance, the security, the adaptability requirements, all of those give you a template. Then for when you're designing your engineering, okay, I know this, my power budget is 5 watts for this subcomponent. So I have this. Okay, now when I'm designing my engineering, I know I cannot go over 5 watts, right? That's the beauty of it. You basically get like a checklist of things, and then you design for those constraints. And if something is not physically possible, you can change it a little bit, but it gives you like this very defined template where you can work on it, and you ensure that it will work with everything that it has to work with. Because sometimes it happens that you have very big teams working on things, and then when they come in to assemble them, it just doesn't work. Or you have a team develop something very expensive and eat up all of your budget, and there's nothing left for the rest of the mission. So you do all of this before you even start doing an engineering drawing. And then once you have it, you can go into the development. Of course, you will have some kind of understanding of how it will work. But the idea of this is that you will do all of this, and then you can find the best solution that fits all of those through working on it. So once you have your all of those, the concept of operations, it basically refers to the concept of operations of the system. So what I already explained, how does the system work according to the stakeholder requirement specification? So how would I look into it? So I have an example of this. This is for the mission, for one of the missions that we want to develop. It basically states, okay, this is a very high level concept of operation. So it is launched from a rocket launcher, and the payload has to be frozen at, well, it has to be on a refrigerator stored at 4 degrees Celsius. Then it goes all the way up to the ISS. Once it's on the ISS, we basically plug it into a platform. We have to wait 15 days. While on those 15 days, it has to be able to collect data from the sensors every 2 minutes, and from the cameras every 30 minutes. And then once the 15 days are over, it has to be frozen at minus 20 degrees Celsius, and then it comes back to Earth. This is a very basic understanding of how a ConOps look. The idea is to have a very clear understanding of how all of the mission works. So it goes from the start till the end, to the closure of your project. And to finish up with all of that, once you have the idea of doing these requirements is that you can validate them at the end. So you can do verifications where you plot one requirement over a verification, and if it meets that verification, then your project is ready, right? So you basically do, for example, if my project has to be able to stay under a power budget of 100 watts. You do the test. You test all of your components running at any given point, and if it's less than 100 watts, there you have it, right? That's the way you do it. So there are different types of verifications. You have inspection, which is basically, okay, I manufactured this thing, and it has to have a length of 100 millimeters, give or take a tolerance, right? So you inspect it. If it has the specified length, then it passes. If not, you have to redesign it or rebuild it. The review is more of a team kind of thing. So we do reviews to understand, okay, what's happening. The analysis is more on the computational side. So you basically run tests or simulations. A demonstration is just what it sounds like. You do a demonstration of one subsystem or one component, and testing is more grand scale. So you test various components or various subsystems together, so that you understand how they all work together, and then at the end you do all of the necessary tests to ensure the safety of whatever you're sending. For example, if you're sending the I don't know, a satellite, it has to be able to withstand some vibration tests because it will be subjected to those vibrations during launch. So if it passes that, then it's ready to be launched, right? So, okay. I know it is a lot. Does anyone has any question up to this point? This is a very basic overview of how space mission design works, but I know we didn't have much time, so I had to like go a little bit fast, and I know it's a lot of information. So
Did your team go through every single one of these steps you described
yes,
with no exception? Oh,
yes,
wow.
so okay, yeah, we did all of this. We actually did. So let me show you. We use this as a template. We have simplified it because NASA's is very complicated, and that's part of why they can deliver such very extensive missions, very complex missions with the quality they have. But it also then the trade-off is you take a lot of time doing that. So they've been working on the Artemis rockets for how long, right? But it is necessary for those kinds of very complex projects. Ours was not as complex. So what we did is we set up a mission concept review. So basically we understood like the conceptual aspect of it. These are reviews, so it's just like a milestone along each phase to just know that you're on the right track to completing your project. Then we did a preliminary design review where we basically evaluated like our preliminary design, how it would work, the integration aspects of it, everything like that. Then you do a critical design review, which is like when you have like the last design, that's the last moment where you can make changes. Once you pass that, you cannot change the engineering because it will put in jeopardy other things. And then we did a system integration review, which is this one. And then we did some final tests before the launch, like vibrations. And also we had this spinning test to just know that we complied with everything that was asked of us by the launch provider, as well as some power tests and some mass and volume tests, which is basically something that you know from the beginning and just you work to comply with.
I have a question.
Yeah.
So, yeah, how are you able to put like a time frame for your projects? Like, for some projects, we think that it might take too long. We don't know how to necessarily approach it. So, how do you define the time frame to maintain progress over time?
So there are various ways of doing it, and you can estimate. What I would do and what we did is talk to someone that has already done something similar, right? Or that has a lot of experience with project design, because these things they take a while to learn. If you do the estimations, just be sure to have like a good buffer of time, because these things always get delayed. There's always a problem. There's always something, and you have to account for that. It's normal. It's part of how projects work. But it's not so different from what you guys already do at the university. For example, when you're planning to do like a project for the end of the semester, you have like this end date, and you just have to try to accommodate. Sometimes the time frame is set to you by an external factor. For example, if you have a launch provider that will be launching their rocket on, I don't know, the 30th of October of 2026, then you have 2 years from now, right? And you have to see if it's feasible to do it in that time frame, and then if it is, then you have to plan and account for that deadline, right? You guys have any other questions? All right, then thank you very much for listening to me. I hope it. Do you have one? Oh, okay. Sorry, I cannot. Oh, okay. You're okay. I hope this is useful for you guys. If you have any questions, please let me know. And Manfred, do we still have the time for the activity, or should you guys can do it at another time as well? It doesn't matter. I was just gonna ask like a few questions. So I think if you let me know.
Oh, we have some time. We have like 15 more minutes. So
All right.
I think we're
Okay.
good.
Oh, okay. Okay. I thought it was until 9:15. That's why. Okay. So this is how this is gonna work. I'm just gonna ask you a question about about what we just saw, and whoever answers first gets the prize, right? So my first question is, can anybody tell me what the difference is between the stakeholder requirement specification and the system requirement specification? Yeah.
So the stakeholder requirements, this is more on the financial requirements from what I understand, such as like you mentioned before, the return of investment, like what your expected budget wise. And then the system and environmental is how much are you able to accomplish it technically? Do you have the technical resource? Do you have maybe environmental things that play to your advantage?
Yeah, almost there. Does anyone have anything else? to add to that, but right. Okay, so it is technically correct, but it's broader than that, in the sense that your stakeholder requirement specification is not only the financial side, but it's also like the requirements of the business as a whole. So, for example, more on the side, more on the lines of, okay, we have to be able to do a PR campaign for this, for example, or we have to be able to get, I don't know, um, to do promotional to get our logos on the moon surface, or we have to be able to I don't know, to communicate, to give these results and publish them, or those kinds of things. Those are stakeholder requirement specifications, right? We have to be able to get valid scientific data that is something that we are able to study and do papers on. Those are also stakeholder requirement specifications, and the other ones are more on the system, as you said. So it's more like how will my system work, and then the specifics for it. So maybe what is my power budget? What is my weight limit? What is my volume limit? Um, what actions should each of my subsystems be able to do? How do they communicate with each other? How they integrate? Everything that has to do with the engineering side, like what are the requirements of the engineering side, right? So one is more on the mission as a whole, so general. The other one is more on the engineering side. But yeah, so it's basically correct. So we have our first winner. Okay. Can anyone tell me then what are the next expected booms on the space sector? Like, what are the next big things that we are expecting to happen? Like, what are the next few big trends? Yep.
I'm not sure if it's a valid answer, but although the Artemis program that keeps getting pushed back, unfortunately, I don't know if it's a valid answer.
Mm. Yeah, I'm referring to what we spoke about at the beginning a little bit. Does anyone
I'm
remember?
sorry.
That's okay.
Um,
Yeah.
So I think we mentioned about the microgravity programs with maybe trying to create new cures,
Yep.
medical cures. I forget. And there's one that you mentioned with like rats that they wanted to test with like osteoporosis or I don't know.
Yep.
And I think we also mentioned telecommunications or like trying to use satellite to send data, mobile data and streaming services instead of using it's like signaling tower.
Yeah, that is absolutely correct. So the experiment you mentioned with the rats, it's a very interesting case because it's an experiment. It's a product that we already have that people with osteoporosis use. Uh, that was developed in space, right? So at least a part of it, and that's something that we can have like a tangential proof of that space affects lives here on Earth in a good manner. But yeah, so generally it's not only microgravity, it's manufacturing and research and development in space. That's one big one. But yeah, and the other one is exactly communications, the use of low Earth orbit, like these big constellations of satellites, to be able to offer services from low Earth orbit through communications, through those kinds of applications to Earth. Those are the next expected big trends. So yeah, you're correct.
And also remember the when you mentioned that I think Astrolab you said that they're trying to build a hotel
Yeah,
Hilton?
Yeah, yeah, that's, I wouldn't say that's the next big trend, but it has to do with these new commercial space stations. And that is a huge thing. It's a little bit on the same side of this new R&D, and so these commercial space stations will be able to provide those services, but also tourism and a lot of, so those, like, commercialization of space is a big trend as a whole. That's something that is we're seeing right now. SpaceX started that, and then you have a lot of companies trying to operate more like traditional Silicon Valley companies instead of traditional space companies, in the sense that they want to get there fast, quick, and get a lot of money out of it. Where traditionally you have people, like traditional companies and traditional um, space agencies, they plan the mission for 15 years, right? So that's the difference now. We want to make it a more commercially available in a commercial manner and quicker with big returns. Okay, and my last question is, let me think. Um, what is the, like, what is what is the first step you would take before starting to develop a space mission? Once you have like an idea for a space mission, what's the first thing you would do? Yep.
I think, like, first of all, like to, okay, uh, convincing the stakeholders and but send out the details of, what someone would return.
Mm-hmm.
Sorry, I lost it.
No, that is
Yeah.
okay. You're on the right path. Okay, yeah, that's the absolute first step. And once you have like the okay from the stakeholders, what would you do?
From there,
Okay,
I think it's,
so you went and you pitched your idea, and the guys were like, okay, here, have $100 million to develop your your space mission to Mars or whatever. What would you do then? What's the first step you want to take?
I believe that to, set a time frame, with an agreement where, so the stakeholders would get in return
Mhm.
the X amount of money they send, like,
Yeah, so you are kind of correct in the sense that, yeah, you do have to set up a plan. So what you have to do is like try and look for the project life cycle. How will you meet and make this mission feasible in a time frame that matches all of the stakeholder requirements? So everything we talked about, this is the first step. You get like an idea of how that mission will look like and how you set up phases for each of the parts of the mission once you know it's feasible. So yeah, basically that's it. So congratulations, thank you. And just to finish, I wanted to, well, thank you again for having me. I'm really happy. Let me know if you guys need anything. And this is my email. So if any of you has any doubts or wants to reach out, please feel free to do so. I'd be happy to help in any way that I can. So great to meet you guys. I hope to eventually be able to go back to Costa Rica and meet you all in person. And it would be, or even to Texas. I love Texas as well. I know that we have some people based in the U.S. With us through the um, through the teams.
Thank you. Yeah.
Thank you.
Thank you.
thank you.
Thank you.
See you
Yes,
guys.
Carlos, thank you so much for
No
having
problem.
us. And yeah, hopefully all these people learned something and
Hope
yeah,
to see you one day here.
yeah, exactly. Hope we can have you here someday.
Look forward to
Sure.
it. I think I'll be back sometime next year. So we can definitely plan for that.
Yes, that
And
would
I
be
know I will
lovely.
be on the US as well at some point next year. I think early in the year, so that's also a possibility. But yeah, whatever you guys need, let me know. I'm happy to work with you guys, and I hope this is of value to you. If you need anything like if you need like an explanation of something that we talked about, or if you have any doubts, even if it's not something from the presentation, I'm happy to help in any way that I can.
Yes, thank you so much.
Thank you.
Thank you, Carlos.
Bye.
Excellent. No problem. Glad to be here. See you around. Bye bye.